Ma'am, now it is. Ma'am.
Yes, my screen is visible, Shikha, to all of you.
Yes, ma'am. Yes, ma'am.
So we were discussing about designing an experiment. So main component in case of any designing of experiment is a variable. These are all the components that tend to change. Okay, so there are two components in this. The one is the independent variable, another one is the dependent variable. When we say independent variable, it is the variable that we change on our own. These are voluntarily changed, and we just try to see the effect of these variables on the outcome that we actually desire of. So these outcome or the responses are actually the dependent variables. So we can say that the dependent variables are the responding variables, whereas independent variables are the manipulated variables. So these are two very important components of any design: independent variable and the dependent variable. So in a way, we can say independent variables are actually the factors whose response we actually try, whose effect on the response we try to measure, and dependent variables are actually the response. So this is just a quick reminder we can see over here that when we talk of the variables, they can be divided into they can be of two types, particularly the independent variables, categorical or continuous. Categorical means which cannot, they are not integer based. They are actually, they have discrete answers like yes, no, whether it is a male or a female, the small, medium or a large size, like that. Whereas when we talk of a continuous or the nominal variables, they are the one with the numbers like height, your weight, age, speed, the distance from a particular place. Means in this we just put the numbers, whereas categorical they don't include the numbers. We have the comparisons or the discrete answers are there. Now comes this is also an important component of any experiment. There are constants which we cannot change, and they are always kept as constants, or we can say they are the controlled variable in any experiment. So these are what? These are nothing but the variables that are always kept as constant, and we cannot change them. And this is also very important because unless we keep them under the control, we cannot actually study the effect of all the independent variables that we have included in our experimentation. So these come under the controlled factors. Another component in case of any experimental designing is the materials and the procedures. So materials, we all are aware that all the components that actually are used for the preparation of any formulation. So this includes all that we use for our experiments and how we actually do it. But it is very important to include certain things before starting with the selection of materials or the procedures. We must look for actually we must do the listing of all the variables. We must do actually the repeated trials in order to avoid the error, and we must draw the outline of the apparatus, that how it is going to be like and how we are going to perform our experiments. Then comes the basic terminologies before starting with the actual response surface methodology. So the first thing is the controlled experiment. It is a study where the treatments are imposed on the experimental units, and factors that we have discussed, that all the variables or the things which tend to change, and the one which actually affect the response, whether these can be the formulation variables, they can be the processing variables. So processing variables like temperature or time, or formulation variables like chemical components or the composition. Then comes the next term, which is the treatment. So treatment is actually the combination of one or two factors. For example, if I'm taking up the temperature as 20 degrees Celsius and the time as 40 minutes, so this combination is actually known as a treatment. Another combination will be 40 degrees C at 60 minutes. So that will be another treatment. Then comes the term levels. Levels means the values of the factors. So it could be lower value, the higher value, the amount, its magnitude, we can say. So that includes the level of that particular factor. Next term is the effect. Effect is what? It is actually the actual effect which any factor on the response it does on the response or the mean response. So there it could have actually it could act as a main factor based on this effect, or it could be due to the interaction between the factors. Then another one is actually the response variable. This we have discussed, that this is actually the outcome that we desire for. For example, when we want to prepare a tablet Then we look for its hardness, we look for its the flowability, the dissolution properties, the release profile. They all include your responses. Then comes your design space. This is also very important. See, if you have not still decided your design space, it will become really very difficult for you to work on that particular area. Because I'll give you one example. When we want to prepare, a construct, when we go on for the construction of a new house, we give the architect a particular space that he has to prepare or build a house in 1,000 square feet or a 2,000 square feet. So that is the design space which we have provided to that architect. Okay, so in the similar way, we must select this design space over which these factors can be varied. We cannot go on for values from 0 to the infinity level. Otherwise, it will become very difficult for you to work. The another one is actually your design points. These are actually the values of the factors at which these experiments are actually conducted. So one design point will mean one treatment that I've told you that how we go on for the combination of the two factors to make one treatment. Now, these are normally we keep them as a coded, like if it we have placed it as -1, it is a low level. If it is a +1, it is a high level. Then comes the next term, which is also again very important, that is the response surface. So it is actually the mean response at any given level of factors in a design space. And then you can simply, we have such softwares where we can just look, by looking at those response surfaces, the color of that particular graph that we have obtained, it will give you that how much is the significance of the individual factor on that particular response that you are studying. So these are some of the points that why these designing of experiment is very important. First and foremost thing is that it improves the performance of existing processes. Then it reduces the time to design. It improves the reliability and the performance of products. We can have the better product and process robustness. We can have reduced cost with these experimental designing. We can have the maximum yield with this. So overall, we can say that it is to systematically investigate the process and the product variables that will ultimately affect the quality of our product. So that is actually our main goal or the objective of these designing of experiments. So major goals are actually to avoid the experimental artifacts. See, like I've shown you that picture that where they were throwing the things on the walls. So they all come under the experimental artifacts, that whatever feels like good to them, they just design it in such a way to get the type of result that they want. So this should not be there when we go on for the experimental designing. We must eliminate the bias, and that is why there are certain things that we perform while experimentation, like we do the randomization. We can pick the sample from a sample, like we have a sample of 100 vials. So we can pick up the sample from any of the vials. That is randomization. Then the blinding is there. It is either the single blinded or a double blinded studies are there. You must be aware of this is principally done in the case of the clinical trials, where in case of single blinding, the patient is not aware what is given to him, but whereas in case of double blinded studies, even the doctor is not aware like which patient is being given the placebo or the treatment. So that is actually these are some of the things that we do to eliminate the biases. Then comes the reduction of the sampling errors. So we avoid this by means of replication of our samples. We do the balancing and we do the blocking. I'll show you further how do we do all this. So if we compare our entire process in this way, we have the input variables which is put into the process and then to get the output. So in this, there are certain factors which we can control. So these factors like the processing and the formulation variables we have discussed. Then together with this, there are certain uncontrolled factors. For example, if we are preparing a formulation whereby we are looking into the effect of temperature or the time on a particular output, but we cannot control the humidity of that particular area. So that humidity actually becomes your uncontrolled factor, and that also might affect your the quality of your formulation. So that becomes your noise. Okay, so uncontrolled factors are also known as actually the noises. So key terminologies before moving further are interaction, replication, blocking, and randomization. This all we do to avoid any kind of bias in experimentation. So the first thing is interaction. Obviously, when we are using two or more components, there are the chances that they are going to interact with each other, either in a positive way or in a negative way. And then we interpret it by means of certain interaction graphs. right? So by means of these interaction graphs, we can easily make out that whether the interaction between the two or more factors that we are taking up, it is positive, it is negative, or there is no interaction. So the general rule is that the more the steeper the slope of the line, the more is the degree of interaction. So I'll show you. This is the kind of interaction one where the two factors have been taken, the factor A and the B. So this is at the low level of factor A, it is at the high level of factor A. Then you can see over here, obviously at certain point of time, these two lines are going to interact with each other. They are intersect with each other. So definitely the interaction is there between the factor A and the B. Then the next one, you can see over here, this is the another one. If you see, this is interaction one, this is interaction two. And here you can see that the slope is even more steeper in case of this interaction two type. So you can easily make out that the tendency of interaction or the intensity of this interaction is more in the case of type 2 of interaction as compared to the type 1 interaction. So normally when we were like students, we used to do it manually. We used to actually take up the square of the higher value at B and the square of lower value at B. Then we used to actually subtract it from the factor B with that of the A to analyze the effects. But it was very time taking because we used to do it all manually. But now we have softwares which do it so wonderfully for you in such a small time that you can get the information that whether the interaction is really significant or not. Another one you can see that you can see over here, the interaction, it is directly intersecting. So you can easily say that this interaction is a one whereby definitely the factor A is being influenced by the B or B is being influenced by the A. Then another term which is very important in order to avoid any kind of bias is the randomization. So randomization is what it is. In this, we instead of taking like what do we do in case of experiments? We do the experiment number 1, then 2, then 3, then 4, and so on. But in case of randomization, instead of taking the 1, 2 after 1, we take up the 4 or the 5 run, or sometimes the 10th run. So in this way, we actually avoid any kind of uncontrolled bias that would otherwise affect your experimentation. Then comes your the blocking. So in case of blocking, we try to increase the precision of any experiments by making the blocks. Like for example, in this, what do we do? We prepare blocks in a way that we include 3 or 4 subjects in a particular block. So it is a sort of clusters or grouping that we do to improve the precision of our experiments. So what do we do in this? We run all the combinations at one level at some time, and then when we move to the next stage, we run all the combinations at the next level. So this is also a very important technique, and we have the softwares which do it for you. Then another important term is actually the replication. You should not actually confuse it with the repetition. Replication is it is the multiple experimental runs that we do during any kind of experiment. Whereas repetition is the one whereby we repeat particular experiments. So they just allow us to eliminate the errors or the noises, but replications are very important because they give us the precision and they give us the significance of any particular factor on the particular response that we are studying. Then types of experimental runs, we do 2 types of experimental designs. The one is the screening design, and this is done at the initial stage when we have a lot of factors with us. And in this, we just try to screen out these factors to the lesser amount. As you can see, we try to taper it in a way like a trapezium, where we have a broader end with a more number of factors. And when as we move further, we try to segregate to actually select only the few factors for the further study. Then comes your response surface designs, where we try to determine the optimal settings, which are the best settings available with these availably selected significant factors. So these are the 2 types of designs that we do. This is the general the flow chart that we follow for any kind of experimentation. So in this, whether they are the known factors or the unknown factors, we try to screen out to select the best factors. Then after the selection, we look for the effects or the interactions, if any. If there are no such interactions, then we directly move to the verification stage. Otherwise, we go for the response surface methodology, whereby we look for the best or the optimum combinations of these factors, and then we again move for the verification. So this is the way how we actually do the entire experimental design. So these are some of the designs that are performed. For screening, placket Berman is being used, fractionate factorial is being used, two-level full factorial designs are used. These are the number of experiments that are performed. The levels are 2 in all these. That means either the factors have only 2 levels. And this is the limitation of the factors with each of the technique. With the placket Berman, with fractional factorial, it is less than 4. Then two-level full factorial, it is between 2 to 5. Then comes the optimization, whereby the principal models that we use are the box-Penton design, central composite design, and three-level factorial. And these are in this, you can see that we are increasing the levels also. Whereas in case of box-Penton, there are 3 levels of each factor. Central composite, there are 5 levels of each factor, and 3-level factorial, there are 3 levels of each factor. So, in a way, these are the basic applications whereby we can use this experimental designing approach. So the first step I've discussed is the screening, whereby we select or screen out the major factors, the significant factors. Then we try to actually determine the optimum. We try to improve it by means of certain settings that we perform. And then at the final stage, we try to determine the optimum by means of the response surface designs. So for the screening purpose, the 2 most commonly used methods are the fractional factorial design for resolving the main effects in minimal runs, or the full factorial design to resolve the 2-factor interaction. So mainly these are used for screening and the determination of the any kind of interaction that might exist between the factors. So this is the kind of window that opens up when you click on actually the design expert staties. So here you can see if there are 2 factors, because this is a factorial designing, full factorial design. So when we are using the 2 factors, it will have 2 more levels. So there will be 4 runs. If there are 3 factors, then again, we will have how many experiments? 8. For 4, we'll have 16. For 5, we will have 32. For 6, and so on like that. So you can see as the number of experiments increase, obviously our resources will also be exhausted with it. So then we move on for the fractional factorial design, whereby the number of experiments are being reduced. And as we even move further, you can see the red part. If we see the red part, you can see even we can have the more information with a minimal number of experiments. Somebody's mic is on, I think.
I request everyone to mute your mic. All the participants are requested to mute their mic.
So as you can see from the the color also, we should these red ones are actually very rarely used, and only when we have no other options, or we have so many factors, then only we go for it. Otherwise, normally we stick to the full or the fractional factorial designs. So then how do we actually analyze our outputs? So they have the inbuilt softwares, have inbuilt data system where they determine the half normal plots. They're also known as Daniel plots, where they look for certain the outputs. These are easy to produce. They give a quick visual of important effects, and they can be compared to the reference. So you can see over here, like for example, if you are following my cursor, these are the individual factors like Ag, NOM, sulfate, these BC, DF, these are the interaction effects of 2 factors. And then you can see there is an arbitrary line in this. The more of the factors with combinations which fall into this line, they are considered as the optimum. The positive effects are being indicated by the orange colored, and the negative are indicated by the blue. So you can easily make out that the kind of interaction that you actually desire for your desired outcome. So this is the general overview, that we start with certain settings, we move towards the improvement to get the optimum result. So this is actually our main gist of our experimental designing. We use the regression models in this, as you must have done it in your mathematics classes. Those who had the mathematics also, what do we do in case of regression analysis? We try to make anything as linear as possible, because if we have to draw a relationship between two components, if it is a curved line, then it will be very difficult to draw a relationship between a factor or a b factor. So we try to linearize the line. If we make the line linear, obviously you can say agar wo line niche aata hai, to you can easily say that the factor effect and outcome mein kya response mein difference ho raha hai. If it is moving towards a higher end, you can easily give the difference. But if it is a curved line, the direct relationship between the factors that you are taking up, it will be very difficult to interpret those results. So that is why we go on for the regression modeling, whereby we try to make the line as linear as possible. So we have the first order model, the quadratic models. The first order, obviously, we are not able to study about the interactions, but in second order or the quadratic models, we try to analyze the interactions also. Then we study the lack of fit also in this, so that we can easily analyze that whether our model is fitting into this particular the set of models that we have taken up. So you can see over here, this is a simple curved line, and we try to linearize it, make it linear. Okay, so you can see that if for example if you're following the cursor, this middle one red line, it is the optimum point. So you can see this linear line is not able to move through this. So that means obviously the linear model will not fall into this, because this is quite far away from the optimum. So first order model won't fit into it. Then next comes your this. And this is the linear equation that, for example, this you need not to make it. Otherwise, because if we have to make it manually, it will be very tedious. We have the softwares, those who do it for you. So it is quite near to the optimum. So obviously this model you can take up. This is the first order model, which shows the lack of fit curvature also. So this will suffice your purpose. This is the near optimum, which is the second order model, which is even more nearer to the optimum point. So obviously you can select this particular model, whereby you can study about the interaction between the factors. Then comes your center points and the replication. So sometimes together with the lower and the higher values, we take up the center points also. For example, this is your design space. You can see over here, this middle round one is your center point. So we add these center points to actually it actually allows us to test curvature using a lack of fit test. So this is between lower and higher value, and this is the center point that we do. Then we have sometimes the multi-layered experiments, whereby we do the number of experiments at the same time, in which you can see over here, there is an initial experiment whereby we look for the experimental equipments. We get the initial values for quantities of interest. Then after this, we perform the main experiment, whereby the major goal of our experiment should be clear to us. Then we have the confirmation experiments, whereby we validate what we have already done in our previous experiments. So these are the set of your multi-layered experiments. So this you can see over here, for example, if we are developing a testing method for material hardness, we want to determine the hardness of this particular material. So this is the object which is being used to study the hardness of this particular purple colored material. So there you can see the one variable could be the pressure pin or the tip, and the another is the strip testing material. So they could be, for example, we are using the 4 types of pressure pins in this particular experiment. So do you think that we are going to get the same results? No, because we will have a lot of variables in it. So this you can see, these are the 4 testing strips. Okay, in each group, we have randomized it in such a way. These are the pin 1, pin 2, pin 3, and pin 4. And if the problem is that if the measurements of strip 5 through 8 at the pin 2, is this caused by the strip or by the pin 2? Because we are taking up the 4 different types of pin in this case. So again, there is a lot of variation in this. Another one where if we are taking up the 4 strips, the one which was the down one, this strip testing material, if we are taking up the 4 strips, so we have again the 4 different pins. 1, 2, 3, 4. This is just the opposite of what we have done before. So again, the problem will come in a different way. So we avoid all these kind of these errors by means of blocking. So what do we do in case of blocking is that we try to differentiate between the strips and we try to filter out these kind of differences. So this is the kind of model that is being developed. So ultimate goal of our this blocking is to reduce the error term. This is the error term that we try to reduce it. Again, we are not because we all are not so means I personally can say, although I've studied mathematics in my 12th, but still I think it will be very difficult for us to manually calculate all these parameters. So the software does it for you, and it is very understandable. Then, so if we quickly recall it, we have the fractional factorials for screening. We have high resolution factorials or full factorials for characterization of interactions. And then finally, we have response surface methods for optimization. And then by means of contour plots or 3D surfaces, we can look for the peak or the maximum point. So you can see this picture. By means of, this is the entire design space or the region of operability. Then by means of this optimization, we try to select the region of interest, which is actually the peak or shown over here. This is the region of interest. So factorial design allows us to get closer to this peak, and response surface methodology allows us to climb them. So this is it. So you can see this is the picture of a response surface methodology. Here it is shown the one factor at a time graph where we are not able to study the interactions. Whereas in this, you can easily see there are the two contour lines over here. You can easily see how the factor A is being affected by the factor B. Whereas in case of these one factor at a time graphs, we cannot see such kind of interactions. So these are certain outputs that we actually do in case of these experimental designing. We study about the effects by means of half normal and normal plots. The Pareto charts are there. We try to analyze the ANOVA, okay, to look for actually the significant variables. We do the summary statistics, whereby we look for the signal to noise ratio, or we look for the adequate precision. Then we have the coefficients of fitted model to see that whether our models are fitting into it, then or whether the coefficients are coming to be positive or negative. Then we do the diagnostics also, whereby we look for the residual plots, the box plots. Then we have the model graphs, like 3D contour, the contour plots or the 3D surface plots. Then these are some of the other available plots which are there, the one factor at a time, whereby we study about the interaction effects. Then we have again the interaction plots, whereby we see the effect of changing one variable on the another one. We have the contour plots, the 3D surface plots, and even we have the cubical plots, whereby we can see the combination of three factors, the effect of three factors at a time. So this is a quick checklist for DOE. We must have the objective of the experiment. We must select the constraints on the experiment, that what is the design space in this. We must be able to apply the blocking. We must include the center points to validate our model assumptions. And we must make the clear protocol of execution of experiments. So if these things are clear to you, definitely you are going to come out with the flying colors with your experiments. We have the computer softwares for optimization of pharmaceutical products. Some of them are like Optima, Statistica, Omega, Design Expert, Compact, SPSS, Matrix, Minitab, GRG2, Equip, Extat, DOE Pro, Excel, DOE Wisdom. We have the DOE version. I think 15 has also come up, although we are still working on 11 and 2, which is also very favorable. But you can go for the 15 also. And these are so user friendly that once you just log into it, you are able to do it. The only important part, which is actually very important in case of these softwares, is the interpretation part, okay, after getting the results. So that you can easily do by studying the basics. So I can say that with these techniques, we are definitely going, if we design our experiments in such a way that we avoid such kind of uncontrolled factors or the noises in our experiment, definitely we are going to get the product which will have the uniform quality, which will have a satisfactory product performance. Then these softwares are definitely cost effective, high quality, and you must try it. And we can have a maximum information with a minimum number of trials, and definitely will have a higher reproducibility so that it can be taken up for the scale up also. So with this, these are the softwares that I use, references that I've used for preparing. And last and least, I can say that wisdom lies not only in the amount of knowledge acquired, but in the degree of its application. So this design expert can definitely help us in a way to actually implement what the knowledge that we have acquired through this period. Thank you so much.
Thank you, ma'am. I request you, ma'am, and director, ma'am, and all the participants to rejoin the meeting for the discussion.
Okay, sure.
Thank you.
Is it visible? My screen is visible to all of you, Shikha?
Yes, ma'am.
So the topic that I've selected for today's talk is implementation of science to practice using research methodology in pharmacy. See, I'm really, this topic is really very close to me because whenever we want to go for any kind of formulation, I think proper experimental designing is actually the zest of everything. Because without proper designing, without proper calculation, we cannot go it for actually reproducibility or scalability of that particular product. So in this, the most important thing is actually your experiments. So if I ask, like, what are actually experiments? So to layman, you can, if you ask some layman, so it is simply the mixture of something to create some output that is desirable to us. So this is just on a lighter note. I have included this slide on experimentation, that this scientist is experimenting, and obviously we all want our experiments to be positive, but this is not sure, okay? Because sometimes it happens that our experiments turn out to be negative, as you can see this sad face over here, and where it turns out to be a disaster, and sometimes we get the positive results where the smiling face you can see over here. So definitely we all working in the research events, cover an unknown effect. This is stress upon it. So experiments are, so there are various ways in which we design actually our experiments. While to that, okay, this we are going to publish because this particular thing has stuck on the wall. So this is not actually experimentation. This is simply the key parameters which must be actually, we must do the homework on these particular points before going on for any kind of planning or experiments. So first thing which is very important is the question. Second, the hypothesis which you have to test. Third is the prediction. Both the variables that which we have, these are the actually parameters which tend to change. So we must actually select the variables by means of our literature survey, the preliminary studies. Next comes the controls. What could be the factors that could be controlled? What could be the factors which are not under your control and they form the part of your noise? They are actually your uncontrolled factors. Next is the materials, all the components that will actually contribute towards your formulation. And the most important thing is the planning. So all these come under your experimental designing. So if you actually want to indulge yourself into any kind of research, so you must have all these 7 parameters in your mind before starting any experimentation. So these are the general approaches. Just a quick memo that what are the various approaches of experimentation. The first is a trial and error. This I've shown you, like how those people were actually throwing the stuff onto the walls to indicate that anything which stuck to the wall is actually our result. Or like trial and error method, one example we can say, like if you remember the small children, and we give during their early years, the 1 and 2 years, we actually give them the toys and we ask them to put the some rings onto the holes, and in a way that child actually does it by the trial and error method, and once he keeps on doing it again and again, the accuracy increases. So this is actually an example of trial and error, but this is not desirable in the case of experimentation that we do in the case of pharmaceutical research. The another kind of experimentation is one factor at a time, whereby what do? We keep all the factors as constant and we just vary one factor. So that is why it is known as one factor at a time. So this is definitely the one that we had been doing during our BPharm years, during our MPharm years also. In this, we simply vary one factor and then we study the impact of this particular variable on the other factors or the responses. So this is definitely very time consuming process. A lot of resources are involved, the money is involved. So overall, I can say that looking into the present scenario, it is definitely the waste of time. So then comes the most important part, which is actually the design of experiments, whereby we design our experiments in such a way that we can have the maximum information with a minimum number of runs of experiment, and further we can have the maximum, the reproducibility and scalability to take it to the higher level or the industrial scale up. So this I've just included to indicate that before starting any kind of work, we must have this question in our mind, that what is actually a good question for an experiment? Why we want to move to this particular topic? So that question should be clear in your mind, that what is the origin of that particular proposal? Okay, then after this, we must see that all the components that we have to try, they should be in your hand with you so that you can perform those experiments. The next important thing is that we must have a hypothesis to guide our investigation. So what is actually this hypothesis? This we have to establish by means of experimentations. Okay, we do certain we try to get some tentative or trial solutions based on this hypothesis. So this is like, if we add more sugar into the milk, it will become more sweeter, right? Or if we add the salt into the sugar, what will happen? It will lead to the curdling. So this kind of hypothesis we can actually, this is just an example. This is not the actual research thing that I'm telling you. This is just an example to indicate that the hypothesis, if we'll add the sugar into the milk, what is going to happen? Just a pre-assumption that it is going to become more sweeter, but then we try to establish it by means of experimentations. Similar way, when we add the salt into the milk, it will lead to the curdling, right? So the extent of curdling, which is desirable, whereby the milk gets separated into the curd and the whey, so that is being established by means of the hypothesis experimentation. So this is actually the main part of your it must be the main part of your experimentation, whereby